right, we're off. Chemistry 8.2. So number one is probably the most important word of the chapter, which is a mole. We'll talk more about that once you're in possession of your own papers again, but mole is a big deal word. 2 is a big deal number, which is Avogadro's number, and it's 6.02 times 10 to the 23rd. I'm going to suggest you store that number in your calculator when we get a moment here, because you'd probably rather have that stored than be typing that in like probably more than 100 times over the next month-ish. 4 is a molar mass, and that's our new words. Question about 4 new ones. 5 is dimensional analysis, like it was yesterday. 6, we could be leaking a half point here or there somewhere. So I'm looking for a phrase that says for each element. I would look for you to have multiplication of the right two things. So the correct two things to multiply are mass in AMUs by atoms from the subscript. And then the final thing you say is to add them all up. So hunt around for that. If they forgot the for each element, let's forgive one mistake for full points today. But what I'd be hunting for is for each element, multiply mass, AMUs, number of atoms, subscript, and add them all up. That's a lot. So we'll forgive one misstep today. 2 or more missteps, we can go have some. 7, molecular mass is when you have a compound that has molecules, and that's covalent bonding. Formula mass is when a compound is made of formula units, and that is ionic bonding, and that's our words. Question about scoring that stuff up? Homework today is heavy. There's a lot of math. There's a fair amount of problems, and they like to ABC you up a lot of times. So behind me, I probably have about 8 problems I'll do as samples. None of it is going to be like long as an individual problem. There's just a bunch of math to do today, a lot more than usual. Quiz first. So reading tonight, you're reading 8.3. 8.3 is going to have 5 new points. I have a 3-point question with 3 different blanks. I have a 2-point question with 2 different blanks. I'm guessing they probably have these words pretty well illustrated. There's two really obvious words that get explained. So when you see them, you'll know you've entered an area of importance. They definitely have highlighted this is an important thought. What they haven't maybe done is highlighted that the one thing has 3 items and the other thing has 2 items, but it's there. But 5 new points on that. Compared to today's, from 5 down, I'm just keeping that. 1's going to go backwards. So what is a mole of a substance? So we're going to start with amount. So it's an amount of a substance that has the same amount of atoms, or formula units, or molecules, or ions, which are different little categories of little specks of building blocks of chemistry materials, but it's any of that stuff, same count as there are 12 grams of carbon-12. So why did they pick 12 grams of carbon-12? I don't know. You could Google that if you're a curious person by nature, but somebody at some point figured out how many atoms are in 12 grams of carbon-12? And it was an enormous number, and they gave it a name, and they gave that magic number a name, which is Avogadro's number, which is 6.02 times 10 to the 23rd. So questions 2 and 3 just stay the same when 1 is going backward. Molar mass is going to go backward, and that's pretty much a giveaway point by the name. Molar mass is the mass in grams of 1 mole. So if you take all the math we did yesterday, what was the unit yesterday? AMUs. That was to find molecular mass, formula mass. If they say find the molar mass, you do the exact same math, and instead of AMUs, you put stop saying mole.
Molar mass.
No. It's the mass in of 1 mole. Rewind what I said, anybody?
That's in grams.
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 Just take AMUs goes out, grams comes in. That's the only difference in doing that math.
What did I say?
So molar mass tomorrow, what is molar mass? It's the mass in grams of 1 mole. I'll have a follow-up question. How does molar mass compare to molecular mass? It's the same number, but with,
Grams.
instead of,
AMUs.
we're good. Stop saying mole. Saying mole too much, although mole is an important word. So 16 points a quiz, homework's 5 to 15. I have a bunch of examples behind me that aren't the book examples. They're just like homework straight out of the book. So here's some free homework pieces for you. Take this on in just a second.
How does molar mass compare to molecular mass?
Same number,
But grams.
but with grams instead of AMUs.
Yeah, okay.
No moles. Not moles.
I was just making sure, because the moles was said way too much.
Yeah, we said moles a lot. Mole is the word of the chapter, but it's not the only
The
word.
word of the day.
It's not the only word to ever use.
Uh-oh.
Question about quiz life. Let's store that. Well, we'll wait till we're doing that. But calculator's handy. We'll store it when we need it when we do this. So here's where I'm working. I'm in the book. I'm on page 206. I'm at your homework page. Does anybody have questions about doing 3 or 4 at all? Okay. So 5, it says find the molar mass. A, B, C, D, I'm doing A. So again, like we just conversed, molar mass is the same math you did yesterday. Carbon's number was 12. Oxygen's number 16. If you forgot those, they're coming from the chart, the periodic table. The whole numbers to the decimal numbers.
Yes.
Decimal numbers. So we find those numbers of whatevers, and then do what? Add them up. So that would get me 28. And yesterday you always said AMUs. Today we don't say mole. We say gram. Something about doing molar masses. 6 is, in my opinion, almost too dumb to be a question. But it says if you have 1 mole of this, tell me how many moles of each element do you have? 6 for carbon and 6 for hydrogen. If you have 1 mole of this, you have 6 moles each from the subscript of the other stuff. So that's not going to be particularly challenging. 7 is going to be some dimensional analysis time. So 7a says you have 3.60 grams of aluminum. So I started you off with 3.6 grams of aluminum. We need grams to go out, and we need moles to come in. They ask how many moles do you have? We can get from grams to moles the same way we did here. How did we get grams from a mole a minute ago on this? Where did the numbers come from? Periodic table. So to get from grams to moles, 1 mole of stuff is, somebody with a periodic table tell me the aluminum number. It's I think around 27, 28.
26.98.
Okay, so that's close enough to 27 because we rounded to the 10th, and with those 2 high digits, we'd be there. So let's push buttons. What buttons would you go with? 3.6 divides 27. Punch, 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 punch. It is what it is.
133.
I'll take your word for it. We would go 3 sig figs on this starting now. So what we want to go, you say 0.133? And then we need to say stuff because science teachers get fussy, and I'm a science teacher honorarily for this 42 minutes a day. We would need to say moles and say aluminum. When I was in school, my teacher was even meaner than I am to you about this. I wrote aluminum once just to remind me to write aluminum later. She wanted us to write aluminum on every single step, and if we didn't do that, it was like problems for us. I don't care about that. That seems a little bit of overkill. But it is what it is. Something about the math you're doing on 7. 8, I'm skipping to E. So here is where you start to see my point about the ions. It says you have 4.20 kilograms of calcium carbonate. So if you don't know how to write calcium carbonate, you're doomed. You have no chance. We need to know that calcium is Ca. We need to know that carbonate is
CO2.
See, we're doomed.
What the heck?
Yeah.
We are doomed. Some of what you said was right, but we yelled 3 different things. So CO2, CO3, CO4, one of those is correct.
CO2.
It is CO3.
I was thought I was losing it for a second.
We also have to know the charges because there might be subscripts and stuff on this. We have no way to know that unless we figure it out. CO3, hopefully some of us know, is a charge of 2. Calcium from the table has a charge of 2. So we kind of got lucky and the charges worked and we don't have subscripts. Okay? But if you don't know how to write calcium carbonate, it really doesn't matter what else you do, it's going to be wrong. But we have to know those ions. Question about how we wrote CaCO3? Okay, kilograms will go out. You can't go from kilograms to moles. You can go from kilograms though to grams. And then we can go from grams to moles. And I would believe probably, I'm walking away from my book, but 80 is our goal, mole count. Mole count the goal. Yeah. Do we want moles? 80, find the moles?
Yeah.
Yeah. So numbers, 1,000 is involved in kilo-ness, but where? 1,000 grams make 1 kilogram. It's always 1 mole when we're looking at our periodic table for the grams, but this is going to take like a little bit of a process. So how are we going to get the grams for this thing?
You do the number for the, was that calcium?
So calcium, look it up,
40.1
40.1. Carbon,
plus 12.
it's 12.
And then 3 oxygen.
3 oxygen,
16 times
3
3.
times 16 is 48, plus 12 is 60, plus that is 100.1.
And
Helpful tip for young chemistry students. Would you think you'll ever see CaCO3 again in your life? Yeah. So maybe have a cheat sheet. CaCO3 is 100.1. It was this time. It will be every time. On your homework, feel free to use every cheat sheet you want to use like that, and not like every time have to recalculate what CaCO3 is. But on a test, you're going to have to just do that. And we're not going to spotlight 100 cheat sheets with 1,000 formulas on it. Question there? And math it up. We go the 4.2
times the 1,000.
times the 1,000.
Divided by the.
Divide by the 100. It should be in the range of 42-ish.
It's 42.95 or 41.95, so it's around
42.0. And I would say moles. And I'd say CaCO3. Love that. So 8G. 8G says moles of sulfur in 0.350 moles of aluminum sulfate. So we need to be able to write a formula for aluminum sulfate. And if we can't write the formula for aluminum sulfate, we're done. Aluminum is hopefully good. Al. Sulfate, I think we know that one fairly well.
SO4.
SO4. Charge on aluminum is a little bit unique. It's a 3. Sulfate is one of the 2s. So 2 and a 3. Last chapter, matter. Ions matter. This is the chapter I got. I told you a story when I first prepared chem, the first time I taught it. I got to that last chapter and it said you have to know these ions. And I was like, they're joking. And then I got to this chapter and I was like, oh, they were for real about that. That was actual good advice. And then I went back to the previous chapter and prepared like a million ion lists. It had to be done. So this one, we're not going from moles to grams. What we're trying to do is go from moles of one thing to moles of another thing. So here's where I channel my inner 11th grade teacher who still lives in pieces of my brain. And I am going to write the substances because I'm changing from one substance to another. We're trying to get rid not just of moles, but we're trying to get rid of Al2SO3, 4,3, parentheses. All that stuff's got to go. What do we want? We're hunting moles of something simple, I think. Sulfur. Moles of sulfur, okay. So in 1 mole of that insanity, how many moles of sulfur are there? Anybody with a thought? It's an easy answer. In moles of this madness, anybody a thought on how many moles of sulfur are in that craziness?
Is it 3?
It is 3. Why 3?
Because there's 3 sulfurs in
There's
that.
3 sulfurs. If they said oxygens, how many oxygens does it have?
Well,
12. How many aluminums does it have? 2. We're basically playing this game. Back here where this was like too stupid to be a question, there's 6 apiece from using the subscripts. That's what we're using. If they're asking you to count moles of basic stuff, the moles of basic stuff is just coming from the subscripts. So 3 sulfurs wins. But if we couldn't write the formula, we're done. Yeah, we're cooked. Something about AG? 8I, a little bit different math style. They say we have 1.50 times 10 to the 24th molecules of carbon dioxide. Carbon dioxide formula?
CO2.
CO2. Molecules have to go. In what definition that you'll do a lot does the word molecules appear as one of 4 choices? Word of the chapter. Mole. Okay. How many molecules are in a mole?
That big number.
That big number called
Avogadro.
Avogadro's number. I am never going to write Avogadro's number on the board. This is my made-up definition. Every time I do that, that represents Avogadro's number. Go to college, write that on your papers. They won't know what you're doing. Like, that's just my abbreviation. I don't want to write that number over and over and over again. Avogadro's number, that's the amount of molecules there are in a mole every single time. So let's store that because now we need it. So grab your calculator to store it. First, we need to know what the number is. What the number is? 6.02 times 10 to the 23rd. So 6.02, hit that EE button for scientific notation. 23. And then down toward the bottom left, you have a store button, STO. Go STO for store. And then we need to pick a letter, if you're in Trig and Calc, a letter that's not used by your programs. So I'm not going to use A for Avogadro's number because your quadratic program has A's, B's, and C's and stuff in it. I don't think we have a program with V in it probably, and that's the next letter I hear, V, like Avogadro. So I stored mine in V at some point in my life. So to store it in V, you do the alphabet button and V, and hit enter, and it's there every time you want it. If you want to see if it's there, go alphabet V, hit enter, and it'll show up on your screen just to confirm it is there if you want to do that. But where we're headed now is 1.5, EE button, 24, divide by alphabet V, hit it, and it's gonna be like 25? No, 2.5?
It's 2.5.
Somewhere around there.
2.49. Yeah, 2.5.
So we'd say 2.49 moles CO2. Something there. 10A, little different math, says you have 1.25 moles carbon dioxide recycled, CO2. So we need moles to go out. You could turn moles into like molecules. You could turn moles into grams. Let's see where they want to go. They want to go to grams. So we can turn moles into grams. It's always 1 mole when you turn into grams. How do you get the gram number?
The periodic.
Periodic table. Carbon is 12. Oxygen
16.
16 times 2.
32. 40.
44. We wanted grams, so we just push some buttons. 55, do a 0.0 for a third digit.
Grams.
Grams.
CO2.
CO2.
What was, for 8G, what was the,
I got excited and moved on. So that would be 1.05. It would be moles and S. 13A. 13A says 0.6 moles of carbon atoms. So 0.6 moles, I squatted you to the C. Moles is out. What did we want there? What's 13A counting?
atoms?
Atoms. The number for moles is generally 1. 1 mole has how many atoms in it? Avogadro's number. Let it rip. Recall that V letter times a 0.6.
3.61 to the 23rd.
3.61, 10 23rd. Word, atoms, thing,
Carbon.
carbon. 15A, and then we'll call it quits for a day. 15A tells you you have 1 atom. So we have 1 atom of helium. So we need atoms to go out. There's only one thing you could trade atoms for.
AMU.
Mole.
Moles. No, we could go AMUs. Hold on. Mass in grams, 1 atom. No, but if we need to get to grams, so to get through grams, what do we want to do with that? We'll go from atoms to moles is true because moles can get to grams. So number for moles is generally 1. Atom count in a mole is Avogadro's number. Grams in a mole for that?
1, and then helium's number.
Helium's number is
Where's my periodic table? 4.
4. So all that ones don't matter. Just go 4 divided by Avogadro, and that's going to be so small.
6.64 times 10 to the negative 24.
And then word that survived,
Gram.
and we've been talking the whole time about helium. there's not a lot of questions today where the word changed. Like, for the most part, if you started with CO2, you ended with CO2. There's more problems in this and future chapters where you're starting with like one thing and you're ending with another thing because there's somehow like a transition has to be made. So that's to matter more later. But we're working 5 to 15. I'll have some sympathy on you on the 20-point count for this, and I'll give you one like bonus day for the 20. As long as you can show me tomorrow that you're halfway-ish on it, I would buy you a day. But if you're getting the 20 points out of 20 on the today homework, the 3-4, I need that today. There's no reason to be sympathetic on 3-4. If you didn't do 3-4, like, do that now. That should take you about, yeah, not longer than 4 seconds, but under 5 minutes.
You also send it down
So,
or?
yeah, 3-4. Let's send 3-4 down.
Okay.
5 to 15. You don't have to redo the ones I did. If you already wrote down the ones I did, fine. You don't have to put it on the same paper as anything else. But we're working to finish 5 to 15. Some of them are really, really easy. Some of them is going to be getting reacclimated to dimensional analysis, which you haven't done for a while. So I should see some dimensional analysis on your paper for most of them. Once you cross like to 7, there should be dimensional analysis going. 5, 6, not so much. Question, anything, misunderstandings at all? Stop that.